Hello everybody, my name is Yao Pan and I am the General Manager of GPT. Today I would like to introduce to you GES, which stands for Geological Evaluation System. Hopefully in the next 15 to 20 minutes, I can give you a general introduction of what GES is and what it can do to help you with the geological evaluation. So the title of this presentation is an integrated application that streamlines your geological workflow. When you look at the title, we really emphasize on these two words, integrate and streamline. In GES, there are 14 different modules, starting from basic data management system to well log interpretation to geological evaluation, and then to 3D geological modeling, volumetric calculation, and well planning. All these modules are actually available in GES, and you do not have to switch your software for complete geological analysis. GES is a software application which is designed to take you from point A to point B. In the geological evaluation world, A stands for your input. They are usually your raw well data, well information, GIS data, and sometimes seismic data. And B is your final outcome. It could be your resource and reserve calculation and geological model for reservoir simulation. There are actually quite a few software applications out there in the market. Some are big and powerful, but the workflow might get a little bit convoluted and you might get confused. Some are small and straightforward, but unfortunately, it can only give you a solution to a specific request. What we want from GES is that it can give you a bucket of solutions in a straightforward manner. In order to do that, we introduce three different scenarios. They are geological evaluation, quick modeling, and geology and geomodeling. And let me introduce them one by one. The first one is geological evaluation. It actually works pretty well for the cases where you have a lot of raw well data, but you just need a geological evaluation in a 2D domain. So first, you start with geological evaluation, and then you do well log interpretation, and fluid distribution and production analysis. At that point, you have to decide if your geological model agree with your production data. If it does, you can just go ahead and do the volumetric calculation and well planning. But if it doesn't, you might want to go back to the very first step and do the geological evaluation again until your geological model agree with your production data. And the second scenario is called quick modeling. It is designed for the cases where you already have your interpretation, but you also need to build a quick and reliable 3D geological model. So in this scenario, we actually provide you with two different solutions, one-button stochastic modeling and quick deterministic modeling. And both can give you a complete solution for structural model, facies model, and petrophysics model. Once you have your model, you can go ahead and calculate the volumetrics and do the well planning. The last scenario is called geology and geomodeling. It works for the case where you already have your well data, but you would like to build a 3D geological model out of it. So in this case, you start with geological analysis. Please do not be misled by this single box out here. It actually contains most of the modules in geological evaluation scenario. So after you have built a geological model in 2D, you can move forward and build a 3D model. Then you can calculate volumetrics and do well planning. All these three scenarios, geological evaluation, quick modeling, and geology and geomodeling, they actually cover a full spectrum of geological analysis, and they are designed for the mid to small size firms, no matter if you are an operator or a consulting company. GES runs on data, lots of data. We have data of multi-disciplines, formats, sizes, and vintages. That's why we need a strong data management engine. In GES, we use data tree to organize our data. You can edit your data, group your data, and do data statistics on the data tree. And of course, GES gives various ways to visualize your data. If you have 1D or 2D data, you might want to use spreadsheets. When you have well-logged data, you might want to display it on a log view. Of course, geologists love maps, so we provide map view as well. Last but not least, we are proud of our proprietary 3D visualization engine, where you can view your data in a spatial perspective. When we make GES, the one question we keep asking ourselves is, what does a petroleum geologist do? If we start with the raw well data, how do we get to properties such as porosity, saturation, shale volume? Well, so in GES, we provide you with the log analysis module. Starting from left to right, you can actually edit your data, do the log processing, and then you can normalize your well logs. And once you're satisfied with the quality of your well logs, you can always go ahead and pick the petrophysical models to calculate your petrophysical properties. And in GES, we actually provide you with the very useful petrophysics workflow. Basically, what you can do is you pick your petrophysical models, and then you can save it as a workflow. And then you can apply it to different well groups or even to different projects. By doing this, it can actually save you a lot of time if you have tens of, even hundreds of wells that need to be interpreted. So when it comes to geology, there are several job items a geologist would love to do. For example, well correlation. Geologists would love to pick wells and pick horizons. That's why in GES, we provide them with this. And of course, once you have the horizons, you can always build your thickness map or your structure map. There are actually some software applications in the market. They believe that this is the only job responsibilities a geologist would do, but for us, it's more than just that. Geologists love cores. If they have the core, they would like to do the grain size analysis, and of course, mineral analysis as well. And once they have the core, they can analyze the facies and then use their understanding to pick the facies log. Once they have the facies log, they can always go ahead and generate the facies map. In GES, actually we have this auto facies function, which allows the software to generate the facies map automatically for you. You can use this result as a first pass and then make the changes you would like. And of course, your facies map is not your ultimate product. Your ultimate product is your resource and reserve calculation. In order to do that, you might want to analyze your production data. In GES, you can analyze that data by single well or on a map view. Once your geological model agrees with the production data, you can go ahead and calculate the property map. That actually concludes the geological workflow in the 2D world. But in a lot of cases, geologists would like to step forward and understand the property distribution in 3D. In that case, GES provides you with the geological modeling functionality. For geological modeling, we have to answer three questions. What's your structural model? What's your facies model and petrophysics model? GES actually provides two solutions. The first one is quick modeling. It contains two modules, one button stochastic modeling and quick deterministic modeling. Both modules give you complete solution for structural model, facies model, and petrophysics model. And the other one is interactive modeling. The biggest difference between interactive modeling and quick modeling, especially the one-button stochastic modeling, is that quick modeling takes care of a lot of intermediate steps, while interactive modeling, you will need to do a lot of manual editing by yourself. And of course, interactive modeling also allows you to build structural model, facies model, and petrophysics model. Once you have built your model, you can always go ahead and calculate volumetrics or upscale your model for reservoir simulation. We are extremely proud of our one-button stochastic modeling, which is our proprietary modeling solution that will give you a quick and reliable result. Let me give you an example. In structural modeling, oftentimes you will end up editing fault models. It is acceptable if you only have a handful of faults. But in a complex structure, for example, when you have more than 2,000 faults, just imagine the time and energy you will spend on editing those faults. But with one-button stochastic modeling, fault editing is automatically handled for you. It takes only seconds. Of course, you can always go back and check the quality of those intermediate steps. On this interface, if you click Run one step, intermediate data will be saved. But if you click these two buttons, all intermediate data will be saved in data tree so that you can QC your data. And of course, being quick is not enough. The result has to be reliable. Here is a comparison between modeling result and well picks. Those horizons are actually from models, and you can see they agree with the well picks pretty well. And also, if you take a look at the faults, the fault model agree with the fault picks on the well. And here is a facies section. The facies log is up front, and the facies model is on the background. You can see the agreement is very good. So finally, I would like to bring back the title of this presentation. GES is an integrated application that streamlines your geological workflow. GES provides you with the entire geological workflow in both 2D and 3D, so you do not have to switch to a different software application for your daily job. By using GES, you can get more types of results, better quality, with less time, less resource, and most importantly, less money. And this is our commitment to our customers, and this is what we mean by do more with less. Thank you very much. If you would like to contact us, please visit our website at www.gptsoft.com and leave a message. You can also send us emails to gptsoft@gptoil.com.